In this second video regarding polygons in the coordinate plane, we're going to draw and classify the polygon with the given vertices, as well as find the perimeter and the area. So here we have the three vertices of this polygon, and right away if it's got three vertices I know it's a triangle, but I need to classify it more than that. I need to say what type of triangle that it is. So I'm going to graph it, and plus we have to graph it anyway. So I have my coordinate plane with my axes labeled with their scale, and I graph the point F, I graph the point G, and I graph the point H, and then connecting them I see that there's my triangle. And just by looking at this, we could possibly classify it and say several pieces of information. I know that that line F to H is a vertical line, and therefore I'm going to call that the base. It's the easiest one to do the base, and then I can do a perpendicular to the point G that I would call my height. So I'm going to use that information for the area. And then I noticed that because of this height, it created two triangles, both of which have a base of 4 and another leg of 2. Both of them have a leg that's 4 and a leg that's 2. So I know these two triangles are congruent triangles, and therefore I know that FG and GH are equal in measure, and so I can tell right away that this is an isosceles triangle. But and that's fine, and so we can look at that, and we can also find the base and the height to do the area. But our problem is we have to find perimeter, and to find perimeter we're going to have to find the measures of all three sides. So let's do that first. To find the measure of the length from F to G, we take the square root of the sum of the squares of the differences of the x's and the y's. Subtract your x's and square it, add that to the difference, or subtract your y's and square that. And we get negative 2 squared plus 4 squared, which is 4 plus 16, which is the square root of 20, which reduces to 2 root 5. And we're going to also write the decimal approximation for that. We want both of the exact and the approximate for each one of these. And what we're hoping for is that when we look at the measure of GH, we're going to get the exact same thing, because we saw that by critically reasoning this, we could see that they are the same length. So I take the difference of my x's and the difference of my y's, square each of those differences and add it together, and I get 2 squared plus 4 squared, which is 4 plus 16, square root of 20, which is exactly the same thing as FG, with the length of F to G, which is 2 root 5, and again the decimal approximation. So our critical reasoning was correct in the beginning, and our algebraic or computational distance formula showed that we were correct. Now, to find the distance from H to F, I could use the formula again, but we said in the very beginning, we noticed that from H to F, it's a vertical line. We can just count the squares and we see that it's 8 units. And we call that our base, and we can count the squares again to find our height, which is 2. So we have two ways now to actually prove that we've shown that this is an isosceles triangle. So we're very, very firm in our knowledge of that it's an isosceles triangle. The perimeter, well, we add up each of those lengths, the 2 root 5, the 2 root 5, and the 8, and we get 8 plus 4 root 5 units. That is the exact perimeter. The approximate perimeter would be to add the decimals up. We get 16.94. To find the area, we do half of the base times the height, and so that'd be 1/2 8 times 2, which is 8 units squared. For our second example, this time we have 4 vertices. So once again, we need a coordinate plane, and we have it labeled with the scale on the axes. We graph the 4 points and connect them. And we might first do a little bit of critical reasoning and saying, well, I can tell that it's not a parallelogram because it's very clear that the side MN and the side LP are not parallel. But what about the side LM and the side PN? Well, the rise and the run for LM, the rise I go up 3 and I run 3. So the slope from L to M, rise to run, the ratio is 1 to 1. So this has a slope of 1. From P to N, I rose 6 and ran 5. It does not have a 1 to 1 ratio. This slope is not 1. It would be 6 divided by 5. Okay, that would be that slope. So these two sides are not parallel. There are no parallel sides. Therefore, this is an irregular polygon. It's not a parallelogram or any of the types of parallelograms we know. It's not a trapezoid and it's not a kite. So therefore, we have to use how to find the area of our irregular polygon. And the step for that is to have it inscribed within a rectangle, meaning each of the 4 vertices, it has a point on the sides of a rectangle. So that blue rectangle has been circumscribed about, or inscribed, has the quadrilateral inscribed within it. And we can count the squares to find the length and the width of that rectangle. So it's 8 by 7. Then we're going to look at the 4 triangles, and we're going to find the area of each of those triangles. Well, this first triangle has dimensions of 3, and the legs are 3 and 3, so the area would be 1/2. 3 times 3, 1/2 of 9, which is 4.5. The second triangle would be 1/2, 2 times 4, so it's going to be 4. And this third triangle is 1/2, 6 times 5, which is 1/2 of 30, which is 15. And the fourth triangle is 1/2, 2 times 5, which is 1/2 of 10, which is 5. So to find the area of the irregular polygon, we're going to take the rectangle, the blue rectangle, and subtract the 4 triangles. Well, the rectangle is 8 by 7, so that's 56. The 4 triangles, we add all those up, and that's 28.5. 56 minus 28.5 is 27.5, and so the area of that irregular polygon is 27.5 units squared. And so these are 2 examples of finding area, as well as looking at perimeter and trying to classify the type of polygon, if possible, by given points in a coordinate plane.